Let's look at example 1 from, this is the class example from section 7.2c, volumes with known cross-sections. So number 1, find the volume of a solid if the base is bounded by the curve y is equal to square root of 1 minus x squared, y equals 0, and x equals 0 in the first quadrant. And the cross-sections are squares parallel to the y-axis. So first we need to identify where the shaded region is. Here is square root of 1 minus x squared. Here's the y-axis being x equals 0. Here's the x-axis at y equals 0. So we are building, we're going to be building squares on top of this base. And now I'm going to draw this shape a little more conventional way. So I have my quarter circle here, my first quadrant. I have the y-axis and the x-axis. So here's the shaded region. Now they're telling us how to draw these cross sections. They're going to be squares parallel to the y-axis. So here's the y-axis, vertical. So parallel means that we're going to be drawing these vertical lengths. Before we consider these as heights. With disk and washer method, we consider these as radius. And now we're going to consider these as lengths or bases of different shapes. Okay, so right now I'm just going to call this base, vertical base. Okay, we're still going to go through the same steps, very much the same in the beginning. If it's a vertical base, we're going to do top minus bottom. Everything will be in terms of x, and we're still looking for bounds in terms of x as well. So let's consider the length of this base. So we do top minus bottom. The top of this base of this length is hitting the curve, square root of 1 minus x squared. The bottom of this length is on the x-axis, so that's minus 0. So our base length is simply square root of 1 minus x squared minus 0. Now this base, this square root of 1 minus x squared represents the base of a square, okay, or the side length of a square. So let's consider a shape, a square, all right, and let's label one side as square root of 1 minus x squared. Okay, and if this is a square, then that means our vertical length will be the same. So we're also going to call this square root of 1 minus x squared. So now the idea is, what is the formula for the area of a square? Okay, and the area of a square is simply base times base, or base squared. Base times height, but base and height are the same length, so we can just say base times base. So the area formula for square is simply base times base. We can see that from the formula that's provided, or the formula that's given for you to know. And we simply plug that into our volume formula, because our volume formula is the definite integral of the area of a cross-section, and the area of a cross-section that we're dealing with is area of a square. So we simply plug this in place of the formula. So square root of 1 minus x squared, quantity squared, dx. And the bounds are from 0 to 1, because if we set the square root of 1 minus x squared equal to 0, and if we solve for x, we're going to get x equals 1. So now we just simply have to, we don't even have to worry about drawing the shape. We just have to know how to get to this area of the cross-section, be able to plug into the formula, and be able to produce the right bounds. Okay? So from here we can simplify. The square root and the square cancels out. We go through power rule, and we're going to get 2/3 cubic units. Okay? Example 2. Find the volume of a solid if the base is bounded by the curve y equals x squared and the line y equals 4, and the cross-section are isosceles, right triangles, whose hypotenuse lie on the base and are parallel to the x-axis. So first let's find the shaded region. Okay. We have y equals x squared, that's the parabola here. We have y equals 4, that's the horizontal line. And that is going to produce a shaded region that we're going to be dealing with. Okay. With disk and washer method, we would look to see where, in which direction the axis of rotation is going in. And from there, we can determine whether to do top vertical radius or horizontal radius. The way that we're going to tell here is they're going to tell us in the problem how to draw your cross sections. So here it says parallel to the x-axis. So x-axis is going horizontally. Parallel means it's going the same direction. So we're going to draw our length, our bases from left to right. Okay, so we want it to cover from end to end. No longer are we rotating, so we don't have to worry about starting at the axis. We just have to draw a base that covers from end to end, going in the correct direction. So in this case, it's going horizontally, and we're going from this end to this end. And if we're doing horizontal, that means everything has to be in terms of y. So we have to adjust our equation. Okay, so our equation initially was y equals x squared. And if we solve for x, we get x equals root y. Now root y represents this end of the parabola, and then negative root y, which represents this end. So this equation is x equals root y. This equation is x equals negative root y. So if we do right minus left, the right endpoint of this length will be root y. The left endpoint is hitting the curve negative root y. So if we do root y minus negative root y, we're going to have 2 root y. Now this base, they're telling us this base is the hypotenuse of a triangle. Okay, and the formula that that you can use if you're just given the hypotenuse of a right triangle is 1/4 hypotenuse squared. Okay, so if you were to look at the shape, this is what the shape looks like. We're building these triangles that have this shape on top of this base. Okay, so imagine we have this triangle that is coming out towards you, and we're stacking all these triangles from this y value all the way to this upper y value. So we don't have to draw it, we just have to be able to apply the formula into the cross-section volume formula. So the hypotenuse is 2 root y, and we simply plug into our formula here. So, and also our bounds are going from 0 to 4, the lowest y value to the highest y value. And the formula, we just plug into the cross-section. Our cross-section formula is 1/4 hypotenuse squared, and the hypotenuse is simply what we found here. So this will simplify to be 4y, and the 4's cancel out. We can go through power rule, and we're going to come out to 16/2 or 8 cubic units. Okay, one last example. We have find the volume of a solid if the base is bounded by the curve y equals x squared and the line y equals 4, and the cross sections are semicircles whose base are perpendicular to the y-axis. So again, we have actually the same shaded region. We have the y equals x squared, we have y equals 4, and so we have the shaded region, and they're telling us how to draw these lengths or bases. It says the base is perpendicular to the y-axis. So the y-axis is going up and down. Perpendicular means 90 degrees, so that means we want the base to go from left to right, okay, horizontally. This is the same equation, so we can again solve for x. So this right curve is root y. This left curve is negative root y. We do right minus left, root y minus negative root y, and we're going to get to 2 root y. Now, if you look at the semicircle, this base represents the diameter. So there's we can adjust the formula for area of a circle, area of a semicircle, to that of using a diameter. So I adjusted the formula up here. You can think of a semicircle as 1/2 pi r squared, or if you're using diameter, you can think of it as pi over 8 diameter squared. And all we're doing is we're taking radius, replacing it with diameter over 2, and then squaring it, simplifying it, and it comes out to be this formula. So we're going to use that formula, pi over 8 diameter squared. So our diameter, okay, is 2 root y, because that's if you look at the shape that's created, this is the diameter of the semicircle. So 2 root y is the diameter, and if we plug this into the volume formula, again, everything's in terms of y, so we go from 0 to 4, lowest y value to the highest y value. And the diameter is 2 square root of y. Okay, we square that as part of the formula. We're just plugging this in. So this represents the area of our cross section. Before we were doing circles, but now we have different shapes, and semicircles is the shape that we're dealing with right now. This reduces to be 4y, and the 4y reduces to be 16 over 2, or 64 over 2, which is 32. So 32 multiplied by pi over 8, because that's the coefficient that we pulled out from the beginning. And then the 32 and 8 cancels out, so we're left with 4 pi cubic units.